These are the notes for Monday, March 31st. First off, everyone get out your note guide. Miss Weihart should have given that to you already. So we're going to talk about path difference interference. We're going to talk about the Young double slit experiment. Path difference interference is where we're going to start. So when I take two waves that start in phase, start from the same point, same source point, they go to the same detector point, but they go by different paths of different lengths. Remember our traveling wave equation that had that piece of omega t plus kx. So at different positions, different lengths away, they're going to have different phase. They're going to be a different point in their cycle. Now, if they happen to be exactly in phase, whether it be because the two paths are the same length, or because the two paths are the right distance so that they will be exactly in phase, then you're going to get full maximum addition. They're going to add together exactly, and you're going to end up with double of each single wave packet. You're going to end up with twice the single wave packets. If they happen to arrive if the path difference happens to be such that they arrive completely out of phase, in other words, the peak from one path is the trough matches up with the trough from the other path, then they're going to have what's called destructive interference, and they're going to completely cancel each other out. There are also many places where you're going to have something in between the two. They're not going to completely add together, but they're not going to completely cancel out. This is what happens if you sit in a room with speakers and the speakers are different, or you're not right on the center line between the speakers. Some frequencies you're not going to hear at all. Some frequencies are going to be real dim, and some frequencies are going to be real loud. This is why this happens. It's called path difference interference. So, how would you find a way to make the waves completely cancel each other out? Well, everything is going to have to be 180 degrees out of phase. So the difference in paths is going to have to correspond to 180 degrees in the wave equation, in our wave equation, in our sine wave. So what corresponds to 180 degrees? The characteristics of our wave: frequency, wavelength, speed of travel. Out of those three things, which is going to be the easiest to get us to 180 degrees? Remember, we're talking about difference in path length. So what's going to be the easy way to get to 180 degrees off of that? I'll give you guys a moment to think about that. Think about it. Go ahead and pause the video at this point, and once you've gotten an answer, start the video back up. What would correspond to that difference would be exactly half a wavelength. So to get them to identically cancel out, the path difference needs to be a half wavelength. Now, what's the path difference needed for them to... It's called constructive interference. where they're going to add together identically, where you're going to have peak equals peak, trough equals trough. What do you think the path difference, a non-zero path difference for that would be? Because obviously if the path difference is 0, then they're going to be at the same place. Once again, pause the video here, come up with an answer, and when you have an answer, when you have an idea what the answer is, start the video back up again. The answer to that would be a full wavelength. If it's a full wavelength difference, then you're going to wind up getting completely constructive interference. You're going to wind up getting and adding together maximally. Now, are you going to find other path differences that'll do the same thing? Yes, there will be more path differences that will do that. Obviously, if it's 1/2 a wavelength, then 3/2 of a wavelength will destructively interfere. 5/2 will destructively interfere. Any odd half wavelengths will destructively interfere and completely cancel out. Any whole number of wavelengths will completely constructively interfere, will completely add together maximally. This concludes path difference interference. Pretty straightforward stuff. But path difference interference is important when getting into talking about the Young double slit experiment, which will be in the next video up. Thank you very much, and have a good day. Be ready for the next video. Next video will be up. Should also be done today as well.